So here we want to explain how the diagram given below can be used to prove Pythagorean theorem. First thing we want to talk about is what is Pythagorean theorem. Pythagorean theorem is used to find side lengths a lot, very typically used to find side lengths, but it's really a theorem about areas. So if I take a triangle, a right triangle that looks like this, what Pythagorean theorem basically says is if I take this and create a square, this area, and then I create a square here, plus this area is going to be equivalent to the area of the square that's created with this side length. So let's call this side length C, this side length B, and this side length A. The area of this square right here, both of these sides would be A. So this would be A times A, or just A squared. This would be B times B, or B squared. And then this right here would be C, and the area of this square then is C squared. So what it says is the area of this plus the area of this is going to equal the area of this for any right triangle. That's essentially what Pythagorean theorem says. And we can obviously use it to find side lengths, but that's really the theorem. So how do we relate that to this? Well, this particular um, shape here, we've got a square, and we've got a couple different ways that we can represent area. So I'm going to represent area in the first way I'm going to represent area is I'm going to take the sides. So this side right here is has a length of A and then B. So we have to combine these two lengths in order to get this side. So in other words, this has a side length of A plus B. Well, same thing over here. This side plus this side creates this whole side length. So we get A plus B for this side length. So I know that my area then is the side times the side for a square. So I've got A plus B times A plus B, or A plus B squared, however you want to write that. Okay. Another way that I can write area though is I can take all these pieces. So let's say this is triangle 1 and this is triangle 2. So this whole shape is made up of 5 different pieces. Okay. So all these smaller triangles actually have the same dimension. They have the dimension A, they have a height of A, and a base of B. And if I want to find the area of one of them, the area of one of them is going to be 1/2 the base times the height. That's simply how we find the area of a triangle. So the base in this case is B, the height in this case is A. So the area of each one of these is 1/2 A times B if we just kind of rearrange our letters. Well, let's look through. Because all these have the same dimension, I've got 4 of these things. So the area of the triangles equals 4 times 1/2 A times B. So the area of the triangles is going to give me 4 times 1/2. That gives me 2 AB. And then we got to throw in the area of the square in the middle here. So the area of the square, that square has dimension of C. So the area of the square equals C times C, or C squared. So another way that I can write the area of this thing is to piece all of these different things together, and all of the pieces added up is going to give me the whole thing. So I've got all of my triangles. The area of those was 2AB. And then the area of the square, the blue square in the middle here, is going to be C squared. So because I have 2 equivalent expressions, I can basically just set these equal. I know that these are both expressions for the area of this thing. So actually I saw a little mistake here. This is not A plus B times A plus B squared. It's just A plus B times A plus B. So let's go ahead and write that. A plus B times A plus B is equal to 2AB plus C squared. Expand this, so whether you've learned FOIL or double distribution, A times A is A squared, A times B is AB. And then we move on to this one. B times A is another AB, and then B times B is B squared. And that's still equal to 2AB plus C squared. All right, last piece here. I've got 2ABs here. I've got an a squared and a b squared. It's equal to 2ab plus c squared here. So I want to combine my like terms. So this like term right here, this is an ab and this is an ab. If I just subtract that from both sides, those will cancel. So those are gone. And I'm left with a squared plus b squared equals c squared. So this is the math behind the Pythagorean theorem. And the explanation, I'm going to try to squeeze this explanation in right here. The explanation is that finding two different, finding equivalent area formulas and combining like terms, or simplifying, however you want to explain that, gives us Pythagorean theorem.